All right, welcome everybody to a video on solving radical equations. Okay, now they don't look that radical in the form of the expression, but the radical is given this the name for this particular notation here. Now we are known to call it a square root, but in its context, it is a radical. Okay, the index of this particular function. Let me just kind of really quickly go over radicals. Is a number that we put here. In this case, we don't put 2 inside this radical, or 2 as an index if it's just a square root. It's just known as a square root. But you'll notice in number 3 I'm going to talk about the cube root. So if there is a 3 here, then we have ourselves a cube root. All right, so I know that there are 6 example problems here, and feel free to fast forward or rewind or look towards another problem. But I do encourage you to take a moment, pause this video, work these problems out the best you can, and then kind of work your way through the video. I'm going to sit and go through all the problems. I will make sure to write them right here so you can see as I work these problems. Okay. Now the main thing that you want to make sure that you do is get the radical by itself. I overemphasize that today, and I will continue to overemphasize it, is that we need to get the radical by itself. Okay. And to do so, I need to kind of do a little algebra here. Now, I started out with a little bit more advanced problems in this set. Some on your practice problems are not as advanced, but I wanted to hit kind of the main stuff here. So first thing I want to do, add 3 to both sides, just like I'm solving a regular equation, a two-step equation, treating the radical almost like a variable, because I'm going to try to isolate it. So you'll notice I have 3 times the radical, or the square root of x plus 2, and so I'm going to divide by 3 to isolate the radical. Again, similar to what I would do if I was solving an equation. Right? So now you notice I have isolated the radical. Now, the inverse operation of square rooting something is to square it. So if I want to eliminate the radical, I'm going to square it to both sides. So in doing so, that leaves the radical gone on this side, x plus 2, and equals 5 squared, which is 25. Now you're in a two-step equation problem in that we're just going to subtract 2 to both sides, and we get an answer of 23. Now very quickly I'm just going to check to make sure I am right in this scenario. And so if you just, you don't really have to write this out, you can kind of look at it here. So if we have 23 plus 2, which is 25, the square root of 25 is 5. 5 times 3 is 15. Minus 3 is 12. So I'm going to call that good, and then that is a good answer there. Okay, so next problem here. Let me try to make this a little bit bigger. Hard eraser will kind of maximize this a little bit. There we go. Now we can erase a lot larger. Okay, so number 2 here. Number 2. We're going to have 2 times the square root of x over 3 minus 5 equals 13. Now don't let this square root of x over 3 kind of confuse you. It's still a radical, and I still need to isolate the radical. So I'm going to do similar to the steps I took in the last problem. And then I'm going to do some simple algebra to isolate the radical. Divide by 2, and so we get the square root of x over 3 equals 9. And so now what I'm going to do is I'm going to square both sides. And so we would get x over 3 equals 81. And now this is an algebra concept that, although it looks like a fraction, yes, but understand I'm taking x divided by 3. So what is the opposite of dividing by 3? Hopefully you said multiply by 3. So I take the same steps, multiply by 3. And in case you don't have a handy calculator around, think of 3 times 80, which is 240, 1 times 3, which is 3. Add those together, you get 243. All right, so hopefully you got the right answers on those. I'm next going to talk about a couple unique situations that you may run into. In this case, I have the cube root of x plus 1 equals 4. Now, not much is going to change here. I'm still going to isolate the variable, all right, similar to what I've been doing. Okay, but now I'm just going to change up just a little bit because I'm taking the cube root of x plus 1. So what's the inverse of doing a cube root? Well, if you answered cubed, then you are correct. All right, so now I have x plus 1 equals 8. Okay, remember 2 cubed is the same as 2 times 2 times 2. So that would be 8. It's not 6. All right. And if I subtract 1, I get x equals 7. Now, although I forgot to check the last one, I apologize. Let's check this one to make sure. So if I have 7 plus 1, which is 8, the cube root of 8 is 2. 2 times 2 is 4. So I know that my answer is correct. Hopefully I'm not going too quick for you. Certainly you can rewind to make sure that you grasp that last equation here. So if I'm working number 4, 5x plus 1 minus 3 equals 2 square root x plus 1. Now this problem is a very unique situation. You'll notice that we have the square root of x plus 1 on both sides. Now it takes a little bit of thought and a little bit of algebra thinking, but if I were to subtract the 2 square root x plus 1 to both sides, I treat this radical just like I would a variable. So essentially I have 5 square root x plus 1s minus 2 square root x plus 1s. So that would leave me with 3 square root x plus 1s minus 3 equals 0. Okay, we're treating the square root of x plus 1 almost like a quantity, almost like a variable in itself, which essentially is what I'm trying to do, which is isolate the radical. And so if I add 3 to both sides, I get 3 times the square root x plus 1 equals 3. If I divide both sides by 3, I would get the square root of x plus 1 equals 1. Square both sides, and I get x plus 1 equals 1, or all that work left me with x equals 0. So let's just take a little look here and see if that does work out. So 0 plus 1 is 1. The square root of 1 is 1. 5 times 1 is 5. Minus 3 is 2. So this side equals 2, just in case you want to take some notes. And then we have 2 times the square root of 1, which in this case would be 1. So 2 equals 2. So I know that I am correct in my math there. All right. That one's kind of a tricky one there. Now, it is important to recognize the difference between numbers 4 and 5. All right, x plus 6 and square root of 2x. You'll notice that the radicals are not the same in the problem. Okay, so we can't use the trick of just subtracting square root over 2x and making negative at 2 and all that. Right? In order to do the trick I used on the last problem, they have to be the same expression inside the radical. Okay, so make sure that if you had this, it's kind of a little trick, a cool algebra trick in case you are lost. And you'll notice that in this case, although we have radicals on both sides, there also are no other, there's no coefficients, there's no constants at the end, and so I'm in a unique space where I can just take both sides squared and get x plus 6 equals 2x, and then I'm just going to solve for x. In this case, I'm going to kind of break my rule and put my x on the right side, and I end up with, I end up with 2x minus an x, which will leave me x, which in this case, x equals 6. Just to make sure we are correct, let's test that out. So 6 plus 6 is the square root of 12, and equal to the square root of 2 times 6, which is 12. So I know that my answer is correct. All right, so we're moving right along here. We're just about done. Number 6 is going to take me a little bit of time here, but if you would like, this problem is a little bit more, brings in some oldie but goodie things for us in the form of factoring. All right, so the first thing I want to do is I want to isolate the radical like I've been doing. So I would get the square root of 14 minus p equals, I would add p to both sides, and I would get negative 7 plus p. Now this looks confusing to me. I don't like negative 7 plus p because it looks ugly. I like to put my highest powered variable in front, which in this case there's only power of 1, so I would have p minus 7. These mean the same things. I haven't changed anything. So now I'm going to take the square to both sides, similar to what I've done on 1 through 5. So what we have here is 14 minus p equals, and I'm going to take p minus 7 squared. Now understand that's not, do not write this please. It is not p squared plus 47. Alright? It is, that would mean you're just distributing the square sign. No, this is, the answer to this is p minus 7 times p minus 7. So if you were to FOIL that, you would get p squared minus 14p plus 49. Okay, if you just distribute the squared, you miss this middle term here. So p squared minus 14p plus 49. As you get better at foiling, you'll recognize these and do these a lot quicker because you just take p times negative 7, negative p, add them together. You kind of get the pattern going. All right, whew. So the next thing I'm going to do is I'm going to keep my p squared positive. So I'm going to put all my stuff on this side. Again, breaking some kind of rules that I like to keep, which is keep everything on the left side. So now I have 0 equals p squared minus 13p plus 35. Okay, so to answer this question, thinking about it now, is what are two factors? Make sure I'm doing everything correct here. Do I have everything going on the right way? Plus p, negative 13p. I have 35. And so I'm going to leave it with this, is what are two factors of 35 that when added together would equal negative 13? All right, so if we went over here, equal negative 13. Can you guys think of any factors of 35 that equal negative 13? Tomorrow we'll start with this problem. It would be a good refresher to kind of get our juices flowing. So you already got a head start if you can find one of those. And so have a good night. Make sure maybe I made a mistake somewhere. But if I didn't, oh geez, I was panicking myself here, and I see where I made my problem. Problem I was saying it has to be factorable because I make sure I picked out factorable problems. And here's my problem right here. I'm sorry for the delay here. This is 2p, so I would have 14 minus 2p equals p squared. Hopefully I haven't made any noticeable mistakes on the last one. So we get 14 equals p squared minus 12p plus 49. And if we subtracted 14, 0 equals p squared minus 12p plus 35. Kind of caught myself in a mistake right when I'm making a film. All right, so in this case, I need to find two factors of negative 12 that would, or sorry, catching on my words here. Two factors of 35 that would equal negative 12. And so if you figured that out, that would be negative 7 and negative 5. So it would be x minus 7, x minus 5 equals 0. That would mean x equals 7 and x equals 5. Now, with this unique situation where we have two possible solutions, it would be beneficial to check both of the solutions. So, for example, if I do 7, let's plug 7 in. So I would get 14 minus 14, which would be 0. And if I plug this in, I would get negative 7. And if I plugged in 7 here, I would get 0 here. Or, sorry, I guess the whole equation equals negative 7. Man, I'm having a bad with this one. So this would be 0, and if I plugged in 7 here, it would be negative 7. So if I added 7, it would be 0, 0. Now in this case, if I try 5, so it would be negative 5 plus 14 minus 10 equals negative 7. And if I add 5 to both sides, I would get the square root of 4 equals negative 2. A dead giveaway that a solution does not work, that if I isolate the radical and it equals a negative number, that is impossible. So therefore that x equals 5 is not a possible solution. So my only answer is x equals 7. I apologize on number 6. It looked as though doing all the problems in a row very quickly caused a little trouble there. But hopefully this lesson helped you, and I'll be happy to help you tomorrow. Thank you.